Today, we are building a bridge. Seriously, not one with steel and concrete, but one made out of code. We're going to connect the deep, technical architecture of a powerful AI service directly to the awesome experience you get when you use it. So let's dive in. Look, you're a professional, right? You need tools that just work every single time. You need a prompt optimizer that isn't just some clever algorithm, but a totally reliable piece of your workflow. So the big question is, how do you actually know if a tool has what it takes? How can you be sure it's not going to fail on you right when you need it the most? Well, the answer is that top-tier performance, it's never an accident. It's the direct result of deliberate, really thoughtful engineering. And that is our bridge. See, on one side, you have your needs, reliability, accuracy, speed. And on the other, you have the technical foundation that actually guarantees them. In this explainer, we're going to walk you right across that bridge. Okay, let's start with the first and maybe the most critical pillar of our bridge, a service that's robust and reliable. This is that simple, foundational promise of an experience that is just always on. We have all been there. You are deep in the zone, you're in your workflow, you hit optimize, and nothing. An error page. Your focus is just shattered and your entire process is broken. That is the absolute worst-case scenario, and our architecture is designed from the ground up to prevent it. So, how do we pull this off? Well, if a critical component, say the main optimization engine, fails to load for some reason, there's a function called load router that immediately detects that failure. And instead of crashing, it activates a fallback. The key here is that the system adapts instead of just giving up. And the proof is right there in the response you get back. You don't get some cryptic error code. You get a valid response with your original prompt, but it comes with a low confidence score and some metadata that clearly says fallback_mode. The system is being totally transparent, telling you, hey, I couldn't do the full optimization, but I'm still here for you. And this is exactly why it matters so much. For you, the user, it means your workflow is never just completely stopped in its tracks by some catastrophic failure. For whole business, it demonstrates high availability and business continuity. This is really the difference between a clever toy and a professional-grade service. All right, let's move to the second pillar of our architectural bridge, accuracy. Because, it's not enough for the service to just be on. It has to deliver high-quality, consistent results with every single request you make. The secret ingredient here is a concept from the FastAPI framework called lifespan management. I want you to think of it like a pre-flight checklist for an airplane. Before the application even thinks about accepting your first prompt, this process makes sure that every single critical AI component is fully loaded, configured, and absolutely ready to perform at its peak. And what's on that checklist? All the big stuff. The core optimizer, the intelligent router, all the database connections, the whole shebang. Everything is brought online in this perfectly controlled sequence. So the bottom line for you is this: no cold starts, no weird, inconsistent results just because a component wasn't quite ready. From the very first click, your prompt gets the full, undivided attention and power of the entire, completely initialized system. That's how you guarantee peak performance every time. The third pillar, holding up our bridge, is all about speed. A tool can be reliable, it can be accurate, but if it's slow, it is just frustrating to use. So this pillar is all about delivering a fast, scalable, and lag-free experience, even when thousands of other people are using it at the same time. And this is a brilliant way to understand how we ensure speed at scale. The system has two different kinds of health checks. A live check basically just asks, hey, is the server turned on? But the ready check is so much smarter. It asks, are you fully initialized? Are your databases healthy? Are you truly ready to handle a request and deliver peak performance right now? So why does that little distinction matter so much? Because in a big, large-scale system, a traffic manager will only send your request to a server that says, yep, I'm ready. This design prevents you from ever hitting a server that's slow or overloaded or maybe still just starting up. It's the architectural guarantee of a snappy, responsive experience. And now we come to the final, and you could argue the most important, pillar of our bridge, security. You have to be able to trust the tools you use with your professional data, and that trust has to be earned through really robust, enterprise-grade security. In this architecture, security is not a feature that's just tacked on at the end. It's a fundamental part of the system, woven into the very fabric of how the application handles every single request and response. It does this using something called multi-layered middleware. The evidence is right in the security headers that are included in every single response. You've got stuff that prevents click-checking, middleware that ensures all your data is encrypted, rules that control who can access the API. It is defense in depth. The bottom line here is just simple peace of mind. You can use this tool for your most sensitive professional work, knowing that your data is protected by multiple, overlapping layers of security. It creates a safe and compliant environment by design. So there you have it. We've crossed the bridge. We've seen how these very specific, deliberate architectural decisions aren't just, technical details for engineers to geek out on. They are the very foundation that creates a superior user experience and gives you a real advantage in your work. So this is our promise to you, built on those 4 pillars: a robust service that is always on, an accurate one that delivers consistent quality, a fast experience that scales without any lag, and a secure environment that you can absolutely trust. It's all connected. And that really leaves us with one final thought. The whole goal of all this complex engineering is to create a tool that's so reliable, so fast, and so trustworthy that you never even have to think about how it works. It just does. And isn't that what great technology is supposed to be all about?